as in um, the force that is pushing it, right? So it can add up and then it can move much faster. So this jerky action is called lunging. If the actuator has an overrunning load, a metering flow control will not work. So if it is overrunning, then this cannot be used, and the valve will also shift if it is vertical. If the vertical rod is making it extend. Since the fluid flow cannot enter the cylinder's cap end first fast enough, so vacuum sort of vacuum will form, and the cylinder will then be free. It will be in free fall, and this will be the I mean whatever if metering flow is adjustment is set, it will be in free fall because it is in downward direction, right? So gravity will win, and this it will start to free fall. The pump will continue to supply metered fluid to the cap end of the cylinder and will eventually fill the I mean the vacuum that was being created. So once the vacuum falls, the cylinder can produce full force. So here you can see the DC valve and blind end of the cylinder. The metered fluid enters the cylinder, which controls speed and speed of the piston. So when the DC is manually shifted to right side, the flow from pump passes through the compensated flow control valve into blind end of the cylinder, and the exhaust fluid is directed freely to the reservoir. So now we move on to something called meter out speed control system. Circuit. So here, as we had discussed earlier, a meter out is it is a speed control method which can be done by adjusting the other end, as in the part where the fluid flows out through the other end of the um, DCV. I mean, sorry, the double acting cylinder. So you don't give it in the supply part or the part way or the portion where we supply the air in. We do it on the part where the air is ejected out. When we control the speed of the lightning cylinder using this method, then it is called meter out speed control circuit. So here you can see that it is manually shifted to the right side. The flow from pump passes to the blind end of cylinder, and the exhaust fluid is directed through flow control to the reservoir. Due to this, the movement is regulated, and there is a restriction on the rod inside. Thus, piston moves slowly. So when we adjust the flow control of the what's it, the of the orifice, based on how much it is being turned, how much it is open, the orifice is open, the speed can be changed. Next one comes is called bleed off control circuit. What is a bleed off control circuit? Bleed off control circuit is this basic speed control circuit in which the flow control valve is used to divert the fluid to the reservoir. So what happens is the flow control is connected in the pressure line so that the speed control may be in both direction of the cylinder travel. So instead of the previous one, here in both directions it can be controlled. These circuits are suitable for broaching machines, shaping, and planing machines. So we have both directions of travel, right? So these sort of devices where the control can be done for both, let's say like if it is a metering circuit, it can be metering for either extension or retraction. Or on the other direction, if it is a meter out, it can be either for extension or retraction. It cannot be for both. If it is a metering um, extension circuit, then it will be a meter out retraction circuit. So it is like vice versa. Okay, let's avoid the confusion. So Whatever direction the speed control is done for that particular actuation motion, it is called metering for that particular actuation. So it is for only one direction only. But for bleed off, it can be for both the directions. The bleed off circuits may be used in hydraulic motor, brake circuit, and concrete mixtures of truck. We'll also start about something called sequence circuit. So sequence circuit is nothing but um, you would have heard of something called a sequence. So what is a sequence? Is something like one starts followed by the other one. The continuous process where one after the other follows. So this is called a sequence. So where would you need multiple double acting cylinders, two or more multiple double acting cylinders to be working in a sequence? Let's take an example. So as we had discussed in the class, we'll discuss about and we'll discuss about same thing again. Let's assume we have two double acting cylinders. One double acting cylinder is used to push the records. So the example that we discussed was the records. Once your exam is over, it has to be punched so that it cannot be used, right? So it has to be punched. If it is done manually, it is a bit laborious process because the class strength might be like 60 or higher. In some departments, in some classes, it is way higher than that, right? So in order to avoid that, we can automate this process. So let's say like one piston moves the record and the other one punches it, and then followed by that, the other one can move it out of the um, let's say like the work volume. So there will be first. So how should this work? So all of the